Hey everyone, and welcome back to another tutorial. In this tutorial, we're going to be building our very own prediction market inspired by platforms like Polymarket. You've probably heard about prediction markets by now, particularly after the US elections in 2024. We're going to dive into what they are, and we're going to build a very simple version of one for ourselves. We will cover how to write the smart contract and deploy it to the Etherlink network, and we'll also write the front-end side of the application as well. First, I'll show you a demo of what we'll be building, and then afterwards, we'll take a look at the theory of prediction markets. We'll talk about how they work, what prediction markets are, and the different models that power their pricing models. And then right after that, we'll dive into the code. So let's jump right in and start with a demo of our simple prediction market. Okay, so right here, this is our prediction market interface. Right now, our wallet is not connected, but I can connect my wallet. And as you can see in this interface, we've got the market with the question. We've got the price as well for each side that you want to place a bet on. So if you want to go on the yes side, it's 42% probability for yes right now and 58% probability for no. So price also represents what the market sentiments are. Right now, in this market, the market sentiment is that 42% of the market believes that there would be a new BTC all-time high by December 31st of 2025, and 58% of the market believes otherwise. And as you can see here as well, we show if the market is resolved or if the market is still active. We also show the volume of the market, and then we show what the expiry date of this market is. And right here, I've just got some cards that helps us to resolve the market and also claim our winnings. But let's actually do a very quick example using this demo right here. This prediction market is deployed on Etherlink, and we're going to look at how to interact with the contract that powers this prediction market on the Etherlink testnet explorer. So if I head into the explorer right now, I've loaded in my ABI so I can interact with the smart contract deployed for this prediction market. And before I get started, I need to connect my wallet. So I'm going to click on MetaMask here, and I'm going to log into my MetaMask wallet. And I'm just going to connect my testnet wallet on Etherlink. And once my wallet is connected to the contract on the testnet explorer, I'm simply going to go into the create market function. As you can see, these are all the functions that I have within my smart contract, and I can interact with them from the testnet explorer. So I'm going to go into the create market function here, and let's give it a question. So I'm going to say, will England win the World Cup in 2026? Right. So this is a nice, fun question that is quite popular right now. And then I'm going to say this should run for the next 7 days. I'm going to put this in seconds, and then I'm going to click on write. And when I click on write, I'm going to get notified to sign this transaction with my MetaMask wallet. I'm going to click confirm. And once I click confirm, you can see transaction has been confirmed. I can also view the transaction details if I want, just to see it on the Explorer. But right now, I'm just going to simply go back into my prediction market application. As you can see here, our question now shows up on our prediction market application. And the question, which is very popular right now, will England win the World Cup in 2026, is up there. And as you can see, our market starts off at 50-50, so 50% for yes and 50% for no. So those are the probabilities. And prediction market smart contract accepts Tezos or XCZ as a native token for interacting with this market. So now that we are in here, we can actually decide that we want to place a bet. So you can see this ends in 7 days from now, which is the 19th. You can see that the market is active, and I can decide how much I want to put on this market. So I'm just going to start off with, let's say 99 Tezos right here. So before I click on place bet, first I'm going to connect my wallet to the prediction market application. I'm going to click connect up here. And you can see we're using ThirdWeb here to power our wallet connection. So I'm going to click on connect a wallet, and then I'm going to click MetaMask. And as you can see right here, my wallet is now connected to this application. So with my wallet connected, I can go ahead to place a bet. I can click on the place a bet button. And once I sign the transaction and come back to our prediction market application, you can see that we've got 99 Tezos in the market right now. The market still expires on the 19th of September. And you can see that the probabilities for both sides has actually moved around now. So it's now 54% for yes and 46% for no. That's the probability in this market right now. And now we can have someone else bet on no, or we can have more people bet on yes, and then when we're done, we can come down here to choose the winning outcome and then eventually claim winnings. So if I click on claim winnings for this market, for example, you can see winnings have already been claimed. So we can see that this works correctly. And once we get into writing the smart contract for this application and also writing the front end, you would have a prediction market just like this ready for you to use. So that is the demo, and this is a simple prediction market that we will be building in this tutorial. And before we jump into the code, let's quickly talk about what prediction markets are. First, prediction markets allow people to buy and sell based on their beliefs. And a prediction market is typically made up of three components. So first, we've got the question, which is what the market is based around. We've got the resolution date and time. So this is when the market is going to get resolved and winnings get split up amongst the winners, and the losing side and the winning side are decided. And then we've also got the options as well. So we've got the options for yes, and we've got the option for no. And then we've also got the probability or the price for whichever side that you decide to go with. So right now in this market, for example, the chances of yes is currently 40% in the market and the chance of no is 60% in the market. And that also reflects the price of yes and no. Now, there are different models for computing the probability or the price for buying yes and no shares or for price discovery. Polymarket, for example, uses an order book model, which works very similarly to a stock trading platform. For every bet that you place on the buy side, there must be someone on the sell side willing to buy your bet. But in our example, we're going to be using a very simple fixed model, which is a variation of a pari-mutuel model, where each share or each winning share has a fixed price and is calculated using a formula. And we're going to show that shortly. But before we get into that, let's take a look at the Polymarket platform and see how Polymarket works. So if I come to polymarket.com, you can see that these are all the available markets that are running right now. You can see that there are different sections as well. I can go into the sports market, I can go into the crypto market, I can go into geopolitics, tech, culture, world economy, and so on. But let's take a very simple example. So Elon no longer world's richest before 2026. Right now, there's a 53% chance. There's $498,000 volume within this market. And I can say yes or no. So I can decide that I believe in this outcome and choose a yes, or I can select the option that reflects that I do not believe in this outcome and click on no. So I'm going to click yes here. And when I click yes, you can see once I put in $10, it also shows me what my returns are going to be. And as I increase the amount, it also shows me what my potential returns are going to be if my prediction is correct. This is very similar to the prediction market that we're also going to be building today, except that our prediction market uses a fixed model. Now, some other models of prediction markets is the automated market maker model that uses liquidity pools to determine prices. So now that we actually understand what prediction markets are and how they work, let's look at a very simple example on the screen right here to drive home the point. And so in our hybrid pari-mutuel model, and the reason why this is a hybrid model is because in a pari-mutuel model, typically payouts are done at the end of the market, so at the close of the market. Also in a pari-mutuel model, you don't calculate probabilities after every bet. But because this is a hybrid version, we calculate probabilities after every bet, and we'll show that shortly. So when we start off in this market, the market question is, will the central bank cut interest rates in December of 2025? And this market expires on January 1st of 2026. And the market starts off at 50% probability for yes and 50% probability for no, which is why we've got 50 cents on yes and 50 cents on no. And these two probabilities add up to 1 right now. But we're going to start off this market by seeding it with some virtual liquidity to make it easy to calculate price and also to avoid massive price swings between one bet and the next. And I'll give you a good example of that. So if you look at our formula here for calculating the price of yes and the price of no, you see that the price of yes is equal to the price of a seeded yes share plus the price of a real yes share divided by the sum of the seeded yes and no shares plus the sum of the real yes and real no shares. So real yes and real no shares are actual shares that users deposit money or deposit tokens into our market to purchase. Seeded yes shares are basically shares that we put into the market to kick things off and to avoid massive price swings. Now, if you look at this here, you can see that because we're seeding the market with 1,000 yes shares to start off with, the price of yes then becomes 0.5 based on our formula, and the price of no becomes 1 minus 0.5, which is 0.5. We do the inverse of that as well for the price of no and then the price of yes. Like we explained earlier, when there's no virtual liquidity, there's going to be massive price swings between one bet and the next. For example, if we're using this formula here, and there was no virtual liquidity in the market, essentially what would happen is if the first user buys 200 yes shares and we divide that by 200 yes shares, we essentially end up with the number 1. And that means that that's the 100% probability that the event is going to occur, which we don't really want to happen because the price that each bettor enters into this market with is dependent on the probabilities. So that's why we're sitting in this market with some shares just to kick things off. And let's look at some sample transactions within our market. So imagine that in this market, user 1 puts $100 on yes, and this $100 is going to mint some tokens. So this is transaction A here. The current price of a yes share is 50 cents per share, and the bet amount that the user is putting is $100. And so the price of a yes share is 50 cents. And so the user is going to get $100 divided by 50 cents, which is 200 yes shares. And so we mint 200 yes tokens for this user. Then the new price of yes, based on our formula up here, you can see we're adding the real yes to 1,000 seeded yeses, which is 1,000, which is 1,200. And then we're adding 200 real yes shares again to this 2,000 that we've got down here, which is 2,200. And so the new price of yes then becomes 0.55, and the price of no yes is actually going to be 0.45. Now, imagine that user 2 then comes in, and user 2 is like, yes, I'm also going to take a yes position in this market. And user 2 puts $110 on yes in this market. Transaction B, the current price of a yes share from up here is still at 0.55. The bet amount is $110. And the number of yes shares you can get for $110 at 55 cents per share works out to be 200 shares. And the new price of yes then becomes 1,400. So we're adding 200 more real shares into this market divided by 2,400, which gives us a price of 0.58. So the new price of yes becomes 0.58. And then the new price of no becomes 1 minus 0.58, which is 0.42. Now, user 3 also comes into the market and they want to put some money on a no outcome. Now, this transaction is also going to mint some tokens. And because the current price of a no share is at 42 cents per share, and user 3 is betting $84 on this market, and so they can get 200 no shares in this market. So the new price of no then becomes 1,200 divided by 2,600, which is 0.46. So we're using this formula up here again, just adding another 200 shares into this market. And so the price of a no share then comes down to 0.46. Now we got another user 4. So user 4 comes into the market. They also want to put some money on no. And they put $92 on the no outcome, which user 4 puts $92 on a no outcome, and the current price of a no share being 0.46, the bet amount being $92. The amount of no shares that user 4 is going to get is going to work out to be 200 no shares. Now, the new price of no then goes up to 0.5, and the price of yes then goes up to 0.5 as well. As you can see, we've got 400 real yes shares and 400 real no shares in this market, and that brings our market to be balanced once again. So it's 50% probability for a yes and 50% probability for a no. So based on these bets, let's see what has happened in our market. So if we look at this table down here, user 1 bought 200 shares, so user 2 also bought 200 shares as well. They bought them at different prices, $100 and $110. And user 3 and 4 also bought 200 shares each, coming in at different prices as well. And in total, our market now has about $386 in the pool. Now, remember, in a hybrid pari mature model, the payouts are calculated at the end of the market because the pool is divided amongst the winning side. Users on the losing side lose all their deposits in this market or all their bets in this market, and the losing pool gets divided up between the winning side shares. And I'm going to explain that here as well. Now, assuming that the central bank doesn't cut interest rates and the no side wins, the payout per share then becomes the total amount in the pool, which is $386, divided by the winning side shares. Right now, the winning side shares is 400, so 400 no shares. And that works out to be 0.965 per share. So for every share that you own in this market, you get 0.965 in return if you're on the winning side. So user 1 and 2 get $0, and user 3 and 4 get 200 shares priced at 0.965 per share, and they get $193 each. User 3's profit works out to be $109, and user 4's profit works out to be $101 in this market. And this is pretty much how our smart contract is going to work. And now we're going to get into writing the smart contract side of our prediction market application. Okay, so now that we understand how prediction markets work in general, let's get into writing our smart contract. So the first thing that you want to do is you want to clone the starter repo from GitHub. And I've included the link in the description below. So clone the repo first. I can cd into the smart contract repo by just doing cd etherlink prediction market contract, and then open this up in my code editor. All right, so now we've got this open. Let's expand this. So before we begin to write any code within our smart contract, we need to set up some basic things first. To make sure that all of this works properly, you can simply come in here and run npm install, and this will install all the packages within this repository so that we can start to code up our smart contract. And the first thing we want to do is we want to go to contracts and go to contract.so. We've got a starter project here for our prediction market. And we're going to import enable. So enable allows us to basically set access permissions for certain methods in our contract. So if we want only the owner of a contract to call certain methods in the contract, we rely on the enable library to do that. And then we've also got our reentrancy guard. So anytime you have a method that modifies tokens, you want to prevent reentrancy attacks on those functions that modify state or that modify the value of tokens within a contract. First of all, we're going to declare two variables to start off our contract. So we're going to have the precision variable. Again, like I mentioned in our example earlier, so we also have virtual liquidity in the pool, which is about 1,000 tokens. So we have 1,000 synthetic yes tokens and 1,000 synthetic no tokens. And we'll multiply that by precision. So we can use these numbers to calculate what the price per share would be. So let's actually write the code that holds information about each market, right? So for each market that we create, there's certain things that we need to track. And let's look at that here. So first, we're going to track the ID of the market. So each market should have a unique ID assigned to it. We're also going to track the question as well, right? So what question are users going to be answering or responding to in this market? And then we have the end time. So this is when the market should end. We also have resolve time to resolve the market automatically. So resolve time should be usually just a few seconds after the market has ended, right? So if you wanted to automate this completely and you had a price oracle pretty much fetching prices, you can use the resolve time to perform an action when the market ends, right? So when the market ends, you have your price oracle make a request to the oracle, fetch the price or fetch the actual result of the market, and then automatically resolve the contract using that outcome. We're also tracking resolved as well. So this is going to be a Boolean. This tells us if a market is resolved or not. And then we track the winner. So like we have here, if 0 is for no, 1 is going to be for yes, and then 2 is going to be for invalid. And then we also want to track the total yes amount in the market. So this is the total dollar value bet on yes, or the total token value bet on yes. Total no amount as well, total token value bet on no. Total yes shares, again, total number of yes shares that have been bought in the market. So this includes both your virtual liquidity and your real liquidity. Same thing for total no shares. We also have market balance as well, which is how much this market actually holds at any given point in time. So if we want to know how many dollars have been bet on yes, or how many tokens have been placed on yes, and how many tokens have been placed on no, the market balance variable is going to tell us that. And then the creator tells us with the wallet address of the person who has created this market. And then we also track if the market is active or not. So we have a Boolean value to track that. And then next, we're also going to have a struct that gives us information about the position held by each participant in our market. For each person that buys a share in this market, we need to know, or we need to understand how much they've bought, what positions they've taken, and the position struct gives us that information. So if you look into the position struct, we've got the yes amount. So this is dollar amount bet on yes. We've got the no amount, which is dollar amount bet on no. We've got the yes shares, which is the yes shares owned by a particular user. No shares, so this is going to be the no shares owned by the user and how much has been claimed. Okay, so next we have the market counter. So market counter keeps track of how many markets have been created using this contract. So we create some simple maps here that allows us to look up information about markets, about position, and about the market that the user is participating in. And next, we're going to keep track of some events. So we want to keep track of certain events that have occurred in our markets. We want to know when the market has been created. We want to know when a bet has been placed. We want to know when the market has been resolved. And we want to know when winnings for your market have been claimed. And then, of course, we initialize our constructor here as well, which is going to be empty right now, so we're not starting off with any information in the market. So let's start off with writing our very first function in our market. The first method or the first function that we're going to have in our market is the create market function. This function starts off a new market using your contract, and we need to keep track of the question. So what question will users be answering? And we also want the duration as well. So how long should this market be around for? And then it returns a value of UIN256. So basically just returns the market ID. So let's get into it. So first of all, we need the duration to be greater than 0. So we don't want a negative duration for our contract. And if someone passes in a duration less than 0, we tell them duration must be positive. So in our create market function, so we're going to increase the market counter value. Remember, we're tracking market counter up here. We're keeping track of how many markets have been created. Every time a new market is created, we simply just increase the market counter value, and then we pass that value to market ID. Then the question is whatever the user passes in or the creator of the contract passes in. The end time is always going to be the current time right now plus the duration in seconds. So this is how long you want this contract to last for. A resolved is going to be false. The winner is going to be 2 because the market is unresolved right now. Total yes amount is 0. Total no amount is 0. Total yes shares is going to be virtual liquidity. So remember, we said we're seeding the market with some virtual liquidity to kick off. And the total no shares is also going to be equal to virtual liquidity. Market balance starts off as 0 since no funds have been deposited into this contract yet. The creator is always going to be the wallet address of the user that is creating this market. And then the market starts off as active, being true. Once the market is created, we emit a market created event. We pass in market ID, we pass in the sender, we pass in the question, we pass in the duration as well, and then we return a value of market ID. The next function is going to be what price should each share cost, right? So if a user says, hey, I want to put in 200 Tez into this contract, we need to know how many shares or how many tokens they should get for the amount that you've deposited into the contract. And our price per share without fees method or function is going to do that. So it takes in the market ID, right? And it takes in if the user is betting on the yes side, so it's going to be a Boolean. So if you can either bet on the yes or the no side. So if you are betting on yes, you pass in a true value here and then calculate how much you're going to get for the amount that you've deposited into the contract or for the bet that you're placing. So the first thing that we do is that we get the market, right? So we find that particular market using the market ID. We get the total number of shares, so total yes shares plus total no shares. And then if the user is betting on a yes position, the user is placing their bet on yes, we take the total yes shares, we multiply that by precision for it to be more accurate, and then we divide that by the total number of shares. The price of yes is always going to be equal to the amount of synthetic yes in the contract plus number of real yes in the contract divided by the total number of shares in the contract. And it's the same thing here as well, right? So we've got the total yes shares in the contract, both the real yes and the synthetic yes, divided by the total number of shares, so which is the real yes, synthetic yes, plus the real no and the synthetic no. If the is yes Boolean is passed in as false, then we go into the else block of this method, and we just kind of do the inverse of what we did previously to calculate the price per share for the position that this user is buying in this market. We also have the calculate shares function as well. The first thing that we do is we find the market. If the market is not active, then we simply return a market not active response to the caller of the function. And then we get what the price per share should be. And then we calculate the bet amount. So whatever amount this user wants to bet, right, times the precision, which we defined earlier, divided by the price per share. If this user is sending a bet amount of $100 and the price per share is at 50 cents, so we return a share value of 200 shares to this user. So, all right, so let's get into the fun part of this contract, which is going to be betting functions. And now we're going to look at the place bet function. So for the place bet function, it takes in a market ID. And again, it also takes in if the user is betting on the yes side or the no side. So the first thing that we do is we find the market using the market ID. We tell the function that the bet amount is the value that the user is passing to this function. So we should actually move the market balance over here. So let's move the market balance over here. Right. We have some validations happening here. If the market is not active, we return market not active. If the market has been resolved, we return market has been resolved. If the betting period has ended, so end times actually passed, we return an error as well. And if the bet amount is less than 0, we also return an error as well. And then we calculate what the market balance should be by just adding the value that the user is passing in to this contract. We add that in there. And then we can calculate the shares as well. So remember, we've got the calculate shares function up here that gets what the price per share without fees is, so what the price per share the user is going to pay is, and then multiplies that or divides that amount by the amount that the user is actually trying to bet. So if the share price is 50 cents per share and the user is depositing or betting $100, then we can see that they get 200 shares. So calculate the shares here, and then we can go ahead and start to update the totals in our contract, right? So if the user is betting on the yes side, we increase the total yes amount by adding the bet amount that the user is passing in, increase the total number of yes shares. Then we can also keep track of the positions as well. So we want to know the amount of yes positions and yes shares in the market, and we can keep track of both of them using the position structure we declared earlier. And we're going to do the same thing for no as well, right? So we increase the total no amount by the bet amount that has been passed into this function. We also get total number of no shares, and we increase that by the number of shares that have been minted for this user. And then we also increase the amount of no shares as well. And in this if block here, we simply just keep track of the user's positions in a market, right? And then we omit a bet placed event using the market ID, the sender, this is yes Boolean, the bet amount, and the number of shares that the user is actually getting for this bet. Now let's look at the resolve market function. In the resolve market function, again, only the owner of the contract can call this function. Resolve market function takes in the market ID and also the winning side. In this function, first of all, we get the market. If the market has been resolved, we send an error back and say the market has already been resolved. If the winner number is not less than or equal to 2, we say this is invalid. This number that you've passed in here is invalid. Then we set the market to true. We set the market active to false, so the market is no longer active. And then we declare the winner, right? So if you're passing winner here, you need to pass in a value between 0 and 2. And we declare that up here. So if you look at what we declared up here, we said the winner should always be between 0 and 1. So 0 is for no and 1 is for yes. And so when you're passing in a value in here for the winner, it needs to be 0 for no and then 1 for yes. So we declare what the winner is here, and then we emit another event down here. Okay, so let's get into our claim wins function. This function runs, or you can call this function, when the market has been successfully resolved. When the market has been resolved, we already know the winner for the market. We know which side has won, whether the yes side or the no side. From that point on, the winners can then claim their winnings. And so we're going to write the function that allows winners to claim their winnings right now. So first of all, we get the market. So we access the market from storage, and then we get the wallet address of the sender making this request. We get what positions they have in the market. We check if the market is resolved. So if the market is resolved, then we can continue on. If the market has not been resolved, then we send an error message back saying the market is not resolved yet. If the position has been claimed, so let's say the user already claimed their winnings, then we also send an error back to say, hey, winnings have been claimed. You can't claim anymore. If not, then we continue on in the function. We set claimed to true, and then we initialize a new variable for payout. So right now, payout is 0. And then we can start to calculate how much a user should actually get based on their position that they've taken in the market. So first thing is that we check if the winner is 2. So remember, 0 is for no, 1 is for yes, and then 2 is for invalid. If the winner is 2, return an invalid payout amount. And then if the winner is 1 and the position is yes, we split the total pool among the yes shareholders. So the winning side shares is always going to be equal to total yes shares minus the virtual liquidity. So this is going to give us the number of real yes shares left in the market. And then from there on, we can then go on and say payout would then be equal to this user's position, right? So let's say the user has 200 shares and the winning side share was 400. So it's going to be 200 over 400 times the total amount of money in the pool. So they get a proportion of the money in the pool based on the number of shares that they've got. So pretty much the same thing for the no side. We get total amounts in the market. So total amount of yes, total amount of no. We remove the virtual shares from total amount of no shares in the pool. And we calculate what proportion of that pool the user who has chosen the no side gets out of the pool. And then if payout is greater than 0, we send the winnings to the sender of this transaction. We remove the payout from the market balance. So market balance reduces. And if that doesn't work, we just send an error back to say the transfer has failed. And then we emit a winnings claimed event. So that's how the claim winnings method works. Okay, so now let's add a couple of view functions that would allow us to see what's going on in the market. So the first one is get user positions. With the get user position view function, we can return what positions a user holds. And we can kind of display this on the front end to the user. If we wanted the user to see, how many yes shares they hold in the market and how many no shares they hold in the market, we could simply use this get user position function to return that information to them. We also have get user market. So this allows us to see what markets a user is participating in within our contract. Get market as well, very simple function, basically just sends you information back about a specific market with a market ID. And then get probability shows you what the price per share is for each market that we have within our smart contract. Okay, so now that we have our smart contract all written up, it's time to deploy it. The first thing that we need to do though is we need to create a .env file in the root of your project, and you need to put your private key in here. So I'm just going to copy the private key variable from here, and I'm going to paste it here. Then I'm going to put my private key from MetaMask. I'm going to do that off screen simply because I don't want my private keys exposed. Now that we've got our private key within our env file at the root of our project, I can then go into my adat.config.js file, make sure that everything looks correct. So we've got our adat ethers library here. We've got our .env here as well. And I can simply just pass in my private key in here. So this looks good to me. And then the last thing that we need to do is we also need a script to deploy our contracts. I'm going to simply create a folder here and call it scripts. And I'm going to create a deploy.js file within that scripts folder. And this gives instructions to Adat on how to deploy our contract. I'm simply going to paste this script right here. And so let's look at it. So we initialize the Adat runtime environment by requiring Adat at first. Once we get that, we are able to make sure that ethers.getSigner is available. And we initialize the deployer. So once that is all set up, we say deploying contract with account, we log this out and we show which wallet address is being used to deploy this contract. And then the next thing is that we compile it. So we get the contract itself, and then we deploy it. And then we get the token address or the address of the deployed contract. And if anything goes wrong, we catch the error and then we log it out in the console. It looks like we're ready to deploy our contract to the Etherlink testnet. The first thing that we need to do is we need to test out the contract and make sure it can actually compile before we try to deploy it. So I'm going to come into my terminal here. I'm just going to clear my terminal, and then I'm going to run npx add compile. Let me zoom this in so it's easier for you to see on the screen. I'm going to run npx add compile. And you can see the contract successfully compiled. And if we come in here as well, we can actually see that the contract has compiled. So if I come into artifacts and I come into contracts, I can see my ABI, which we're going to use further down the line. Next, I'm going to run a command that actually deploys our smart contract to the Etherlink testnet. So I'm going to run npx add and I'm going to run the deploy script to deploy this contract to the Etherlink testnet. So click enter. And you can see deploying contract with my wallet address. The deploy script knows what wallet address I'm using to deploy this contract by pulling from my private key. So by putting my private key in the env file at the root of this project, Adas is able to decode what wallet address I'm deploying this contract from and then deploy this contract from that wallet address. Now we've got our contract deployed on the Etherlink testnet, and I'm simply going to copy this. So I'm going to right click and I'm going to click copy. Then I'm going to come into my browser and I'm going to go to the Etherlink testnet explorer. I'm going to paste the contract address here that we've copied. I'm going to go to the contract address, and you can see this is live right now on the Etherlink testnet explorer. What I'm going to do here is I'm going to paste the contracts ABI into the explorer so that we can interact with the contract from the UI. I'm going to click add custom ABI. I'm going to call this project predictors contract. And then I'm going to paste the ABI in from our smart contract. So I'm going to paste my ABI in here. I'm going to click save. And once I hit save, I can see that all the methods in my contract appears within the Explorer. So I've got my calculate shares method, I've got my claim winnings method, I've got my get market view function as well. Everything shows up in here. And I can basically interact with my smart contract right from within the Explorer without writing the front end part of my application first. So this allows me to test out my contract, play around with it, make sure that everything works correctly, and then go on from there. So I'm going to start off with this question with a new BTC all-time high by December 31, 2025. So as would BTC have a new all-time high by this date? And I can put duration in here as well. So I can basically say 604,800, which is about 7 days. And then I'm going to click on write. So once I hit write here, it's going to allow me to sign this transaction. I'm going to sign it, and you can see this has been confirmed. So this is going to be market ID of 2 because I basically created one before I started recording this. And I'm going to click read here. So this is going to return the new markets that we've got. So we've created a market. You can see the market ID. You can see what the question is. You can see the end time as well. We can see if the market has been resolved or not. The winner is currently 2 because it doesn't no winner yet. Total yes amount, total no amount. We also know total yes shares with our virtual liquidities in there as well. Total no shares with our virtual liquidities also in there as well. And we can see our market balance, and then we can also see that the market is currently active. Now that we have our smart contract written up, we've been able to deploy to the Etherlink testnet. We can also interact with our smart contract using the Etherlink testnet explorer. We can go ahead to write the front end side of our application now. So let's get to that. So to get started, I'm simply going to go in and clone the startup project that I already created for this demo. And I'm just going to do git clone into that project, and I'm going to cd into the project. I'm going to call it prediction markets on Etherlink. Cd into that. Let's clear this and let's open this up in our code editor. All right, now that we have this open, first thing you want to do is you run npm install, and I'm going to run this with legacy peer depths. Give that a few seconds to install. And while this is installing, I'm going to navigate into ThirdWeb because we're going to be using the ThirdWeb library to interact with our contract. So we're going to use ThirdWeb's SDK to connect to our users' wallets. And we're also going to use the ThirdWeb SDK as well to interact with our smart contract on the Etherlink testnet. So I'm going to come in here, I'm going to click create project, and I'm going to call this predictors. Well, I'm actually going to call it just expertise. And yes, so right now we are allowing all domains. I'm going to click create, click proceed. And you can see I've got my client ID here. So I can just copy my client ID, and I can come into my .env file in here. I can create .env.local. And I'm going to say next public third web client ID, and I'm going to make it this. Ideally, you should make sure that this doesn't get exposed, and you should keep this in your .env files that are not deployed to any Git repositories. The next thing we need in here is we also need our contract address as well. So I'm going to do next public contract address, and I'm going to copy the contract address of the contract that we deploy to the Etherlink testnet. Paste that in there. So once we have our third web client ID and we've got our contract address, we're pretty much done with our env file right now. So I'm going to go into lib now, and then I'm going to create an utility file for our contract. All right, so I'm going ahead to create a contract utils.ts file. And in our contract utility file, I'm simply going to paste this script. I'm going to paste this in here. The first thing that we do here is we're using the get contract method from third web. Then we're calling the Etherlink testnet from the third web list of chains. And then we're also getting client from providers. So if you come into providers here, you can see we're basically creating the third web client for us that we can use within our front-end application. And I'm importing that in here from providers. Then the next thing that you need is your ABI. So remember what I said while we were writing the smart contract. Your ABI is an array of objects that is created when you run the compile script using RDAT for your smart contract. So I'm going to copy that as well from my smart contract repository, and I'm going to paste that in here. So I'm just going to collapse this just to make it easier to read. And then, yeah, this file is pretty much done. So remember, we're initializing our client using the third web client SDK in our providers file. And then we're passing in the public contract address for our smart contract in here. And that's from our environment variable file. And then we've also got the chain as well. So we're using the Etherlink testnet, and we're pulling that Etherlink testnet chain information from the third web chains library. And then lastly, we're passing on the ABIs to this get contract method. And this creates our contract objects that we can then use down the line. I'm going to go ahead to edit the page.tsx file. But before we get to that, let's start up the front-end application and run it in our browser to see what comes up. So I'm going to run npm run dev, hit enter. And if I go to localhost 3000, this should load up our starter application with some dummy markets created in there. All right, so in this starter application, it's got some dummy markets in there with some dummy numbers and some dummy yes and no as well. This is how this works right now, but you would see that we kind of change this when we write the code. So let's come out of here and let's go back to writing our code. You can see my wallet is already connected to this because I already plugged third web in here, but we'll get to that shortly. So let's go back into the code. The next thing I want to do is I want to go into my page.tsx file, and I'm going to make some changes to this file. So the first thing I'm going to do is I'm going to import contract from the contract utils file, which we created earlier. And then I'm going to also use the prepare contract call method from third web. And then I'm going to also use this two-way method as well. So two-way converts whatever number we have in it or whatever number we have in Tez to the smallest unit of Tez, right? So we're just basically using this two-way method from third web utilities. And then we also have some tools here to give feedback to the user when they click a button or when something goes wrong within the application. Next thing I'm going to do is I'm going to delete these sample markets from here. I'm going to just remove this. And once I have that done, I'm going to go ahead to replace selected market up here. I'm going to remove that for now. And I'm also going to remove trading model from here for now. And I'm going to paste in the existing market IDs. So basically, existing market IDs are the IDs of the markets that we already have within the market. And I'm going to show you how we're going to use this shortly. So let me take all of this out just to clean this up a little bit more. So the first thing we're going to do is we're going to use the use read contract hook that third web provides to us right out of the box. And I'm going to also create that in here as well. And we're going to import that hook right here. So I'm going to say use read contracts. And once I import that, you can see now that should work correctly. I'm also going to import the use send and confirm transaction hook. Use send and confirm transaction. All right, so now that we have those two, we should be good to go. And with the use read contract, you can see it basically takes in our contract object, which we created earlier. It takes in what method we want to call within that contract as well, which is the market counter contract. That's what we want to call. And then any parameters that you want to pass to that method on the contract. But right now, we're just going to leave that empty because we just want to fetch all of the market IDs that have been created within that market. Next thing to do is to create a variable for our use send and confirm transaction method. And we actually want to bring out this mutate transaction object here. So we're going to be using this mutate transaction object later on. Next, we're going to use some use effect, the use effect hook from React. And I'm also going to import that in here as well. I'm going to say use effect. Now the use effect hook will automatically update the existing market IDs when market counter changes. So if there's a new market added on the smart contract, use effects will automatically update the number of markets that we have showing on our front end and display that to the user. Let's clean this up a little bit. And then next, let's create the method that actually handles when a bet is placed by a user. When a user places a bet, we're going to call the undo place bet method to undo that transaction. So with the undo place bet method, it's going to take a market ID. So what is the market ID of the market that the user wants to interact with? What side are they choosing? And we've kind of typed this to be yes or no. So it's going to be an enum. And then we've also got a bet amount as well. So this should be the amount that the user wants to bet on this market. The first thing that we do is we check what side the user is betting on, right? And if the user is betting on the yes side, then we return true to the is yes variable. And if the user is betting on the no side, we return false to that is yes variable. Then the next thing is that we want the market ID as well. So we convert that to a big int so that we can pass that to our contract. And then they convert the bet amount to way. So remember, the user is going to be betting in XTZ, which is the standard unit of Tez. But we're going to be converting that to the smallest unit of Tez, which is micro Tez, when we're sending this transaction to the contract. And the next thing is to prepare the transaction before we send it, right? So we're going to call the place bet function within our contract. We're going to pass it the market ID as a param, and we're also going to pass this is variable as a parameter as well. And then we're also going to pass a value, which is the bet amount that the user is going to be sending. But we converted this to micro Tez, and we're going to send that off to the contract. Then next, we call the mutate transaction as well. We're going to be calling mutate transaction every time we want to send a transaction to the chain that changes the values on the chain. So we're going to call mutate transaction here, and we're going to pass in the transaction that we've already prepared, including the parameters and the values. And then when we get the result back, we're going to log that result. If there's an error, we're going to display an error, and we're also going to show an error to the user using the toast. So the user is able to place a bet. Next thing we want to do is that they should be able to claim their winnings, right? So the next function that we're writing is a function that helps users to claim their winnings. We can remove this log right here. And again, we can get the market ID. Once we have the market ID, we prepare the transaction again, just the same way we did up here for our place a bet function. Now we're going to call the claim winnings function, which takes a market ID parameter, and we're going to pass a market ID in there. And then we're going to mutate, because we're making a change to the contract. Every time we make a change to the contract, we have to call the mutate transaction method from Third Web. And we pass the transaction that we've already prepared. And then if everything goes right, we log our winnings claim, and then we'll display the result of that mutation. And then we also send a toast to the user showing them that, congrats, your winnings have been claimed. And if anything goes wrong, we show an error saying winnings have been claimed. So typically we know that usually the winnings have been claimed is the error that we're going to get from this method if it doesn't work correctly. And lastly, we're going to go ahead to create the resolve market handler. So the resolve market handler is what makes a request to the chain to resolve a market. And again, we get the market ID just like we've done in our two previous methods or handlers. We get who the winner is, so which side has won. So if that is the yes side, which is 1, or the no side, which is 0, we prepare the transaction again, or we prepare the contract call. We call the resolve market method on the smart contract. We pass in the market ID. We pass in the winner as well. So what side won? And we mutate the transaction one more time, and we pass that transaction in, and then we send a message to the user as well, saying market has been resolved. So the final bit of this is just passing in some HTML and CSS to display things on the screen. And then when you have the connect button, which is powered by Third Web, allowing users to connect their wallets to our contract and to interact with our contract. And then we have also got market grid as well. And we're going to talk about this market grid component next. So the market grid component is going to take the existing market IDs, right? And it's going to use this to display the markets. It's also going to take the undo place bets function. So it's going to take the claim winnings handler as well. And it's going to take the resolve market handler. And then we're just putting toaster here as well, just so that we can display a toast every time an event or something happens within our front-end application, and we want the user to be aware of whatever has happened within our application. So next, I'm going to go into components, and I am going to go to market grid. So we're going to make some changes to the market grid component right now. So in the market grid component, I'm going to change this here. I'm going to say import resolve markets. So import resolve markets from, it's going to come from our components folder, and we're going to save resolve markets. So we got our import resolve markets up here, and we're going to leave this for now. We're just going to work on this market grid component first. So in our market grid props, the first thing we want to do here is existing market IDs. So existing market IDs, and existing market IDs is always going to be an array of numbers, right? And the next thing we're passing here is the undo place bet function. And the undo place bet function is always going to take in some parameters. So it's going to take in the market ID, which is a type of number. It's going to take in a side, which is going to be either yes or no. And lastly, it's going to take a bet amount, which is always going to be a number. And this is going to return void, so it doesn't return anything. Okay, so with that done, the next one is the claim winnings function. So claim winnings, again, claim winnings also takes in market ID, which is a type of number, and it's simply going to return void as well. And then lastly, we have our resolve market function. So resolve market, that takes in market ID as well, which is a type of number. It also takes in a winner, which is going to be a string, and it's also going to return void. Cool. And we can take the rest of this out from our startup project. This looks good. And then we also need to change the props that are being passed to our market grid component. So we're passing the existing market IDs as a prop, we're passing undo place bet as a prop, we're passing claim winnings as a prop, and we're passing resolve market as a prop. And lastly, I'm just going to replace the HTML here with the correct HTML that we need. So I'm going to delete all of this and I'm going to paste this in. And that's our HTML done. So next we can go on to work on our market card component, and I'm going to come to the resolve markets component last. So let's go on to market card. Now within our market card component, we're also going to make some changes to this component as well. So market card is basically every market. So if I come back into market grid here, you can see that we use all of the existing market IDs, which is going to be an array of market IDs. We use that to determine how many market cards we need to show. So we map through each existing market ID in the array, and then we take the market ID from that and we pass that to market card to display information about a particular market. And now we're going to go work on the market card component, which is going to be showing information about each market in our contract. We're going to use memo in here first for performance. And I'm also going to bring in use read contract hook from ThoughtWeb. And then I'm going to use our contract as well from our contract utility file. And then lastly, I'm going to bring in to eat from ThoughtWeb. So this is going to allow us to convert between Tez and microtez. So when we receive microtez back from the contract, we can convert the number back to Tez, so it's easier to read for the user. Next thing we need are our props. So we need to define our props. And this component is actually going to take in undo place bet, which we declared earlier. Like we said before, undo place bet basically takes a market ID, which is going to be a type of number. It takes in a side as well, which can be either yes or no. And then lastly, it takes in a bet amount, which is always going to be a number, and returns void. And then it also just takes in a market ID, which is a number. So I'm going to clean up this market card component just so we can edit it together. I'm going to delete all of this so we can go through it one after the other. Cool. So we've decided we're going to be tracking the overt side. We're also going to be tracking the selected side as well. So if the user decides to take a yes or a no, we're going to be tracking that. If the user overs over a yes or a no, we're going to be tracking that as well. And we're also going to be tracking the bet amount that the user decided to place. And then we're also going to be tracking a show betting interface as well. Basically, we want to be able to display a betting interface with a slider, allowing the user to slide back and forth if the user clicks on a button to show the betting interface. So first, we want to pull information from the chain to get data about the market from the contract. we're going to use the use read contract hook from ThoughtWeb, and we're going to pass our contract objects in here again. We're going to call get market. So get market basically gives us information about the markets. Remember, we called it earlier after we deployed our smart contract to the chain, and then we're going to pass the market ID for that market. So if the market ID is 1, we essentially pass that market ID to the get market method to pull information about our market from the chain. Next, we also want the probability as well. So for each market has an existing probability that is calculated on chain. We want that number as well, so we can display it in real time to users of our prediction market who are trying to place bets. Now, when we fetch information about a market's probability from the chain and also a market object from the chain, we want to use memo for performance and consistency as well, just so that our application kind of works properly and the experience for the user is pretty good. So a lot of what I'm doing here is essentially just typing the results I get from the chain. I then return the title of the market, the end time of the market, the probability that the market is going to be yes, the probability that is going to be no, which is always going to be 100%, minus the probability that is going to be yes. The change as well. So the difference between the yes and no value, the total volume of the market, which is going to be the amount of yes bets that have been placed and the amount of no bets that have been placed. If the market has been resolved, the total number of yes shares, the winner of the market, if there's any winner, total number of no shares, and then this image is just a placeholder for now. Then also the market balance as well. So whatever amount is left in the market at any point in time. And remember that market info is being pulled from our contract using the market ID. Okay, now we're going to get into calculating a potential payout for users of our markets. This potential payout method is actually not that accurate because it doesn't take into account other holders of a position in the pool, right? So when I'm calculating potential payout for a user, you essentially see what happens if you win and you get all the money in the pool. So if you're using this function in a real world application, you need to make sure that this is updated to actually take into account if there are other token holders within the pool. And this function basically takes in a bet amount. If your bet amount is less than or equal to 0, we return 0. And if not, we calculate what your potential payouts would be. And then your profit is always just going to be your potential payouts minus the amount that you deposited in the contract. And then finally, I'm just going to paste in some HTML and CSS code here to help us along. And then I'm also going to replace some of the icons that we're using in here and take this out. Then lastly, I'm going to change up the props here. So this actually takes a prop of undo place bet and also takes a prop of market ID. So I'm going to save that. And then we can go and do the next thing. So what do we need to undo next? If I come back to market grid, we've got market card undooed, then we need to undo resolve markets. So let's go to resolve markets next. So open up resolve markets. I've got a number of imports that we're using here. So these are just UI imports, or UI imports as well. And then use state and use memo for performance, use read contract like to interact with the contract on chain, the contract object as well, and then converting between Tez and micro Tez. Next, let's declare the props for this component. This component is going to take in a market ID. It's also going to take in a claim winnings function and a resolve market function. So in our resolve markets component, we're going to be able to select a winning side, which is either going to be 1 or 2. We're going to change this up to 0 or 1. Like we said in our contract, 0 is no, and yes is 1. And once again, we get information about the market. And then we use memo as well, like we did in the market card component to pull out this information. And then we basically display some HTML as well. Okay, cool. Now that we've got all of this set up, and go back to market grid, make sure that we have everything set up. And changes to this. Cool. All right, so we have a mistake here. Market ID should be a number, and winner should be a number. Okay, cool. So this is clean now. And now we can actually go into our front-end application and check if everything works correctly. So if we navigate into our front end now, we can see that our markets are showing up correctly. And if I click on yes here, it opens up the bets interface, and we can pretty much like slide and decide how much we want to bet on this market. And you can see potential win also shows up as well. So let's try this out. So first I'm going to place a bet of say 10 Tez on this market. So new BTC all-time high by December 31st, 2025. I'm going to say, I'm going to bet on the yes side. I'm going to click on place bets. And this is going to prompt me to confirm with my wallet. As you can see, my wallet balance decreases and we show the 10 Tez in this market. Say someone else comes in and they, decide they're going to take the opposite side to me. They're going to put in 50 Tez into the market. So you can see potential win is going to be 60 Tez. So that's my 50 Tez that I'm betting right now, plus the 10 Tez from the yes bet that we placed earlier. And you can see I'm making a return of about 20%. So I'm going to click place bet here. And I'm going to click confirm again. Again, my wallet balance reduces, but you can see something has changed here now. So the probabilities between the markets has now adjusted, right? So because we've got more no shares in the pool or more bets on no, the market shifts towards no and says that, most people believe that there isn't going to be a new BTC all-time high by December 31st, 2025, and yes becomes a little bit cheaper. Let's actually go on with this and let's say yes side wins. Let's say the yes side wins. We can now click resolve market here. Now I can click confirm and you can see the market is now resolved. And then I can go ahead to claim my winnings. If I click claim winnings here, click confirm, my balance gets updated to 1074. As you can see, the yes side won in this market. And even though the yes side won and I placed a bet of 10 Tez on yes, because I get all the money that no has also bet on this market as well, I also get the 50 Tez from the no side. So I get my 10 Tez for betting on yes that I placed on yes. And then I also get the 50 Tez that the no users placed on no. And my balance gets updated back to what it was originally. And this is how you write the smart contract for your prediction markets on the Etherlink testnet. And then you also write the front-end dApp for your prediction market as well that interacts with the prediction market contract that you've deployed on the Etherlink testnet. So go try it out and let me know what you think in the comments below. See if you can build your own prediction market, see how you can improve upon what I've built here today. And now you can make your market more interesting, more dynamic, more optimal as well for users of your application.